So good morning, everyone, and a warm welcome to this Bioeconomy Cluster Builder webinar focusing on the creation of value from forestry co-products. This webinar is held in conjunction with Scottish Forestry. My name is Kim Cameron. I'm one of the Business Engagement Managers at the Industrial Biotechnology Innovation Centre, and I'm delighted to host today's session. So before we dive into the main part of today's webinar, I'd just like to run through a few brief housekeeping points. The webinar is being recorded, and the recording will be shared on the Bioeconomy Cluster Builder website shortly after the session runs. If you can post your questions into the Q&A box at any time, we'll have a dedicated Q&A session after all the speakers have delivered their presentations, and we'll come back and respond to your questions then. And if we could ask you to remain muted unless you're participating in the Q&A session. So turning to look at this morning's agenda, we'll be together for around 2 hours. We'll begin with a brief introduction to the Bioeconomy Cluster Builder, and then we'll hear from our guest speakers. After that, we'll have an opportunity to answer some of your questions, as I mentioned earlier, and then I'll speak a bit more about the support available through the Bioeconomy Cluster Builder and give you some information about current Innovate UK launchpad for Scottish biomanufacturing. So the Bioeconomy Cluster Builder is an ongoing collaboration between the Industrial Biotechnology Innovation Centre and Innovate UK KTN. And it has three main goals. The first is to raise awareness of the benefits and applications of industrial biotechnology. Second being to connect people and resources who are looking to develop new value chains using biotechnology. And the third is to encourage the uptake and utilisation of Scotland's bioresources. So these are the raw materials that we have an abundance of in Scotland for using as feedstocks to biotech processes. And one of the key mechanisms for achieving these goals is the delivery of events like today's. So without further ado, I'd like to introduce the first of today's guest speakers, Fredrik Östlund, who is Innovation and Process Manager at the Research Institute of Sweden's Processum facility. And Fredrik's going to speak a bit about their capabilities and the great progress they've made in creating value from forestry byproducts. So Fredrik, I'll just stop sharing and I'll let you.
Yeah. So thank you so much for inviting us to this and to present here. So I am Fredrik Östlund. And I've been working at RISE Processum in Örnsköldsvik for about a year as innovation and process leader, working with initiating various biorefinery projects and also working as a consultant in various fields. And before joining RISE, I was working at a startup from the Swedish University of Agriculture that had developed a biostimulant that is used when planting forest. So I was their sales and product manager for 5 years. And before that, I was working at the large pulp industry in this area, pulp and biorefinery. So I was there. I was working as a market analyst and then also with customer-related projects, both when it comes to cellulose, but also to various biorefinery products. I work and now I work at RISE Processum, and we are located in Örnsköldsvik, and that is about 550 kilometers north of Stockholm along the coast. We are located in an industrial area where there is a lot of industrial activity. And we are located here, and we are building a new pilot infrastructure in this area that I will talk about. In this area, it's a large industrial symbiosis park, you can say. We have a dissolving wood pulp producer, and we have ethanol production, and we have municipality heating in this area. And here you see the town of Örnsköldsvik. And what I am to talk about in this presentation is the investments that is being done in this area in strengthening biorefinery infrastructure to speed up commercialization. But before going into that project and that investment, I will give an overview of RISE and RISE Processum that I represent. this is a picture of the building that is to be built. But just to step back, what is RISE? So RISE is Research Institute of Sweden. We are a governmental non-profit industrial organization that works with a mission to support industry and the competitiveness of industry. And RISE as a whole, the entire RISE has about 3,000 employees and a turnover of about $350 million. And a large part of that comes from the business sectors, but we also do a lot of publicly funded projects, both EU and national funding, together with the industry. And as mentioning before, the organization that I represent is RISE Processum, and we are owned to 60% by RISE, by Research Institute of Sweden, and to 40% by our association, interest association. And the companies that you see here, these are companies that have big capacities in pulping. They represent a lot of the pulping and forest capacity in the north of Sweden. So you can say from the middle of Sweden and north. And then there is also consultancy companies and various companies that work with development in this area. And we were founded by a couple of the large forest companies in this area about 20 years ago. And the reason why we were founded was that they saw a need to strengthen resources that goes into long-term R&D in biorefinery products. So not working with the core products such as pulp, paper, and timber, but rather working with developing new product and new processes from the residuals. And that have been our aim. That was our aim already 20 years ago, and that is still our aim. But we have built a lot of capacity in this area over these years, both when it comes to competence, but also when it comes to laboratory and pilot infrastructures. And this project with a big investment in the bioeconomy arena, that is a very big step for us, but we already have a lot of capacity from before working with this. I will give more information in the coming slides on the different areas that we work on. Our funding comes both from regional funding, that we build projects where we have regional funding as a base from the Örnsköldsvik municipality and from the region, and then building projects with EU funding. Then we also have a lot of national funding, various kinds of national funding. And we also have a lot of contract work that we do for companies where they have specific R&D projects where they consult us as a contractee. And as mentioned before, we have a couple of areas that we focus on. One is biotechnology, that have been a focus area for us for, you can say, the last 15 years, building up the capacity in this area. And what we have in this is that we have both various scale of pre-treatment of different biomasses, both wood-based biomass, but also agricultural-based biomass. We also have capacity for enzymatic hydrolysis and for fermentation. And we are also now strengthening our capacity in molecular biotechnology. And I will talk more about that and the different some different examples of projects that we have done. But an important area that we have worked a lot with is single cell protein. So going from by using wood, producing proteins that can subsidize, for example, fish meal and other various protein sources. Chemistry is also a big area for us. And we are working a lot with various chemical biorefinery reaction. We have a flexible ATEX area where we have the capacity to do various scale-ups and a lot of modifications. So when going from the lab and wanting to try in something in bigger scale and see how that works, we have a flexible area for that. Another area that we have worked a lot with is hydrothermal chemistry, both liquefaction and carbonization. Hydrothermal liquefaction is quite a big area, and that's a process that is quite suited if you want to go from a wet biomass such as a paper mill sludge or other various materials that is tough to dry, because that process can take in quite wet material and transfer them into bio oils. We are also building up the capacity when it comes to cellulose nanocrystals and electrochemistry. And electrochemistry is quite a new area, but we are investing a lot in this area. Then we also have a group called the Innovation System Group. And at the Innovation System Group, we build a lot of projects where we come in with capacity from our group, but also building on the resources that we have. We do both projects where we use public funding, but we also do quite a lot of contract work when it comes to, for example, techno-economic analysis and market analysis. And we have also recently recruited an LCA specialist, life cycle assessment specialist, in the biorefinery area that is also working for us. Something else that we are doing and that we are engaged in within the Innovation System Group is something that is called the Forest Business Accelerator. And that is a program that we run yearly together with BizMaker, that is a local incubator in this region, and SCA. And SCA, they are one of the largest forest companies in Sweden. They have a forest of about 2.6 million hectares and produce a lot of both timber and pulp. And they are very engaged in this project, this program, because they would like to see new invention, new ideas feeding into their industry. What we do in this program is that companies that is in the program, they are supported with expertise and then also guidance of financing and also a lot of the benefit for them is the industry network that we sit on. There has actually been companies coming from other parts of the globe to join this program. A couple of years ago, there was a company from Australia that relocated to Örnsköldsvik and to Sweden to bring their development forward, and they are called Cast Material. They are developing various insulation and foams from pulp reject and from nanocellulose. That is something that we see going forward, that this is a good platform for companies that like to come to the region, that they could land within this program. Going forward then, a couple of examples. So when it comes to biotechnology, we have worked a lot with what is called single cell protein. So that is a process where you can use various kinds of agriculture or forest residuals, various kinds of industrial residuals that contains carbon, and transform them into proteins by hydrolysis and fermentation. And we have been running a lot of different projects in the last 10 years. And one such example is a large EU-funded project called SylFed, where we did the bioconversion, and in that project it was tried. This concept was tried in quite large scale, and then also it was used for feeding fish, and there has been a couple of other such projects. And one of the companies that was included in this was Arbion, and built on this project, they continue their plans in investing in such a facility in France, actually. Another such example that we have worked with and following along their scale up is a company called Seagreen. And what they do is that they have, in collaboration with us, developed a process where they used hydrothermal carbonization to be able to handle various sludge volumes, various kinds of sludges from the pulp industry, but also from municipality wastewater treatments. And they have built a full scale in a pulp mill in Finland now. And we were part in the first laboratory trials, but then also scaling it up to container size, their operation before they went for industrial scale. Another example of a company that we have worked with is a company called Cenis Fertilizer, and they were part in the Forest Business Accelerator a couple of years ago, and we have supported them with laboratory work that is the foundation of their company now. And now they're actually stock listed, and they are building production in south of Örnsköldsvik. And what they do is that they take waste material from the pulp and paper industry that they convert into fertilizers, and so they get fertilizer and salt as a product from their process. And what we have been working with them for quite some time, verifying the project in both laboratory and pilot scale. So jumping into the bioeconomy arena, so we are located here in Örnsköldsvik, and RISE has a lot of capacity when it comes to various biorefinery processes. This is a list. I will not mention everything, but what we focus on, as I said, here in Örnsköldsvik, is various chemical processes and biotechnology in various ways. In the chemistry area, we collaborate a lot with the infrastructure that we have in Piteå and in Södertälje. It could be projects such as taking waste material and demonstrating fractionating it and making a bio oil that is upgraded. The bio oil is made in Örnsköldsvik, and then it's upgraded in Södertälje. So why RISE do this investment of strengthening the pilot infrastructure? The core of this is that there is a need, if we should make the bioeconomy happen, there is a need to bridge the gap between laboratory scale, small pilot scale, and making demo plants, making demo facilities. This is a way to make that process, make that transition happen. That we build up the capacity in this area and are able to contribute to new businesses by supporting in scaling up processes. Big part of the assignment is that the focus on why this is done is that it should support the industry and it should the current industry, but it should also create new businesses. And we have a lot of SMEs that we work with in this area that will benefit from this when scaling up their often patented processes, when they like to scale them up. And that could be both in developing the process, but it could also be in generating relevant volumes for trials at their customers. That is also often projects that is important, that you can provide volumes that is significant, that could be used by their customers. These are the major areas. I will not go into details on this, but I will distribute the slides later, of course, so you can look at it later. And important in this is that this is an open infrastructure, meaning that we are very open to build both publicly funded projects, but also to work with contract research in various ways in this infrastructure. And just some examples of the test beds that is built, of the 20 test beds, some examples of the test beds that is built in Örnsköldsvik. Biotechnology is a big area and that we invest a lot in. And end users that we see in this area is that you go from forest-based residuals and other residuals, that can be agriculture residuals also, and convert it into valuable proteins and also single-cell protein, the fish feed or protein supplement for animals that I mentioned before, and various biochemicals. And important in this infrastructure is that we can work in many different scales, depending on where in the scale up, in the process of scaling up the company or the research is in. And important also in this is that it will be food grade, the facilities, meaning that new proteins, new feed tech proteins from residuals can be developed, and also volumes that is generated for trials can be produced in these facilities. Another area that we invest in within the biotech is something that is called a high throughput center. So normally when you develop microbes for these kind of processes, you look microbe by microbe at plates, agar plates. But this is a machinery for being able to screen about 60,000 at the time, and being able to vary different kinds of medium, being able to evaluate many different microbes at the same time. And that is important when you are to develop new products from various residuals, sugars that is not always super pure sugar as in traditional fermentation. Another area that we invest in and that I mentioned before is hydrothermal liquefaction. So we will increase our capacity in this area, and we have a couple of projects that is relevant for this when it comes to residual biomass. And for example, various sludges, biosludge and fiber sludge, together with bark. We have projects coming in on that, where we take those kind of residuals, making the HTL process, and then converting it into biols that is further converted into, for example, transportation fuel. Then what we also do is that we upgrade our ATEX area so that we can work in 250 liter scale, and we also increase the filter capacities. And the ATEX area will be important in demonstrating and scaling up various chemical biorefinery processes. So going back to where we are again, this is quite a unique infrastructure, and what is unique about it is that we have all the way from small scale to large scale, but also that we are in an industrial area working very close with the forest industry in this region. We think that it will be a lot of new developments coming and a lot of new companies spinning out from this environment that we create, that we will see in the coming 5 to 10 years. This was everything I were to present, but I will distribute the slides, and I'm very happy to take questions. But I understood from Kim that we're doing that in the end of the session.
Yeah, thanks very much, Frederick. That was really, really interesting. I mean, great to understand the scale of activity in Sweden, actually, and the wealth of support that's available for industry and across the bioeconomy. So that's great. Yeah, we'll come to questions at the end. I'll hand over now to Miranda. Miranda's commercial director at Sonichem, an iBioIC member company, and they've developed a sustainable biorefinery technology for converting woody biomass to high-value chemicals. So it looks like you're all set, Miranda.
I am.
Yeah.
Thank you, Frederick. Thank you for the warm-up. As a company that's preparing to scale, we understand the value of what you can offer over at Rise. So thank you for having me here today. My name is Miranda. I'm the commercial director of a biorefinery technology company called Sonichem. We have been developing an ultrasonic technology that can extract high-value biochemicals from forestry co-products. So today I'm going to talk a little bit about why we do what we're doing and what the opportunities are within this sector. So petrochemicals are widely used in the production of plastics, materials, cosmetics, the whole range of everyday products. And the need to reduce the reliance on oil-based chemicals is growing a huge amount of demand for sustainable bio-based alternatives. The bio-based chemical market is growing at an extraordinary 9% a year. And yet every year, millions of byproducts of agriculture and forestry are underused, undervalued, and often burnt. Within the forestry industry, as we know from our forestry partners in Scotland, around 55% of a tree that enters a sawmill ends up as valuable construction timber, and about 45% becomes a lower value wood chip and sawdust, which are often burnt, releasing CO2. We must and we can do better than that. So we have developed a technology that can break apart sawdust and the woody biomass into high-value biochemicals that can help to seek to decouple the chemical industry from petrochemicals. If you have a look at the chart over here, anyone working in forestry is very familiar with the demand for wood for construction, which we're seeing an increasing amount when looking for sustainable building materials to build houses. But you look at the right-hand side of this graph and you see that embedded carbon is required for a vast amount of chemicals and derived materials. So imagine or vision a future when we can take the 45% of the low-value co-product sawdust from a sawmill and extract biochemicals can serve this market. This market where you're seeing an increasing demand, around 12% of global oil production is used in petrochemicals, and it's increasing. It's driving more than a third of the growth of oil in the years towards 2030. And this is what we're really trying to look at and create the chemicals for. So I'm going to step back to, we started as a process to break apart woody biomass, which is the really fibrous, tough biomass that you see around, and extract 3 high-value bio-based chemicals for commercial production. We started with some core technology values, which we've really stuck to, true to our sustainability and high-value impact. So we want to develop a unique, low-value process, which would mean it'd be economically and environmentally sound, adaptable to different types of woody biomass. So we're currently working with Sitka spruce sawdust, which is the big commercial forestry co-product up in Scotland. However, the process could also work on hardwoods such as oaks and other biomasses such as oat husks, which is also a big crop up in Scotland. And from this process, we wanted to make sure that all of the biomass, or as close to all as possible, could be converted into high-value green chemicals with no waste, no low-value co-products, and also water use neutral. So really sustainable. And all of this makes for a cost-effective biorefinery process with maximum return on investment. Oops, one too many. So how do we do this? So we have developed a unique ultrasonic process, and the ultrasound is what gives the energy to break apart these woody bonds. So we take sawdust as is from sawmills, and we blend it into a slurry with some water and some mild organic agents. And then we combine the chemical and the ultrasound technology to break down this woody biomass into its core constituent components, which are cellulose, hemicellulose, and lignin. And how this happens is the ultrasound creates this really powerful force called cavitation, which is tiny, weeny little bubbles, which the sound creates within the slurry. And as these bubbles implode, they create these really powerful forces. You're talking pressures equal to the bottom of the ocean, temperatures equal to the surface of the sun. And these forces essentially unzip the chemicals that are the core constituents of the tree and separate them into these 3 product streams, which we're then taking to chemical companies who can process into end user products, which might be cosmetics, food and pharma, composites. So I'm going to move on to that now and talk about what these products are and the sort of projects that we're working on with them. So the 3 core constituents of the woody biomass are your sugars, which is a hemicellulose sugar. So these are mixed sugars, and they're quite unique. You have things like mannose, which is a well-known antibacterial sugar, xylose, which you're maybe familiar with as xylitol, which is a known sweetener for toothpastes and drink products because it's got a really healthy low GI impact. But what's really interesting in some of the projects we're working on within Scotland and outside in the UK with SMEs is those that are using biomanufacturing process for these non-food source sugars. So SMEs that are actively looking for sugars that don't compete with the food chain, that come from a low-value co-product. And these can be used to create a biosurfactant, which is basically like the foaming product that you might see in your washing up liquid or on your face wash. Natural dyes, the dyeing industry is well known for being quite toxic, and also bio-based films. The second project is cellulose, which many will be familiar with as paper or clothing. Our process turns it into a crystalline cellulose, which is a really fine powder, and it's a registered cosmetic ingredient, which is used as a mattifying effect and put in sort of face powders and makeup products. There's also a fantastic UK SME that's making biodegradable microbeads, which would replace plastic microbeads in all sorts of formulations. Bio-based films, think the really soft plastic wrapper that you might find on food. And then it's also a well-known pharmaceutical binder. So it's the non-active ingredient that might be in the aspirin or paracetamol tablet that you would take that would help its absorption into the body. And the third and final product, and is the one that's really generating a lot of research and interest, is lignin. And lignin trees have an awful amount of lignin. It is what gives them their structure, their strength, their rigidity, what enables them to grow 50 meters into the air. And it's got some extraordinary properties as well. What it gives to the tree is an innate UV resistance so that the tree doesn't break down in the sun. It's flame retardant, and it's hydrophobic. It doesn't like water. And it's also nature's aromatic chemical, which makes it a prime replacement for a toxic petrochemical called phenol in resins and coatings. So think your varnish on your outdoor wood table could be made with lignin, which would give these added properties we just talked about. Also interesting for potential cosmetic applications with its natural UV resistant. It's also an antioxidant. And then added to that with this aromatic polymer is the smaller monomers within it are things called guaiacol and vanillin. Vanillin, which you might be familiar with as vanilla. This is what gives your whiskey its flavor when you age it in an oak barrel. So these were really high value molecules that we can potentially target to extract from the lignin, which is really exciting. So looking at the value of all of these, so we take a ton of sawdust, which currently worth about 45, 50 pounds, and can extract about 360 pounds worth of bio-based chemicals by today's sort of market prices that we're working with in the UK. The percentages given here are typical to what we're extracting from the Sitka spruce sawdust that we work with from Scotland. If we were to look at different biomass feedstocks and in particular trees, you would see these percentages change. Lignin, for example, is a lot higher in a hardwood, but it is a slightly different type of lignin. But I believe the next presentation is going to be looking at that. So why does this matter? So there is a huge global demand for these bio-based products that's really been driven by the end consumer, who's increasingly looking for a traceable, sustainable product. You've got increasing regulation where governments are starting to look at carbon taxing. They're regulating petrochemicals, which is really driving chemical companies to look at their supply chain and what it's made of, and really replace these petrochemicals with biosourced chemicals. And it's super interesting at the moment. We're seeing huge demand coming from local manufacturers, big companies, but most of their biochemicals they're importing from overseas. So there's big imports coming from Brazil for the sugars, for the cellulose, which obviously adds a huge cost to the product, as well as a massive carbon footprint because of where it's coming from. So the opportunity to develop a resilient bioeconomy in Scotland using the forestry co-product is really exciting. And there's so much pull coming from the market that it's a great opportunity for us to be working together towards. I'll draw your attention to the biomass value pyramid on the right, which the EU is really starting to put front and center of their policies, whereby from what goes into the sawmill, construction and sort of high value timber comes out top. But for the other co-products, it's really looking at, can we really focus our efforts on making materials, pharmaceuticals, things above fuel and energy. So this is where we're at the moment. So we're based in Melton Mowbray near Leicester, where we're operating a pilot plant. Our original pilot plant was built with a €2.5 million consortium grant. And we've been working with this for a few years now to optimize it into its current iteration, whereby we have achieved a sort of scalable reactor design, which is going to be the core of the planning for the commercial plant, which has started. Throughout this, we've been supported by incredible university projects, some of which have been initiated by IBISE, and also with some partners down south who've really helped us. If we've optimized the technology, given us life cycle analysis support, we really want to make sure that we know that our technology is going to be carbon friendly. And that's been critical. And also looking at the design of our products, which are all quite sort of different to the market. And through this, we've been also providing commercial samples to SMEs and companies to really test and trial the products for their applications. And I really wanted to talk about the importance of collaboration and the value that we've had from the organisations, including ICAST and Scottish Forestry, throughout the development of our process to ensure that we develop a process that's good for the biomass producer and the forestry industry, and also that there's really sort of high value impact uses for the chemicals. Some of these include, we've just been awarded a project via IBIC and the Scottish Innovation with the University of Glasgow, looking at lignins, films and coatings. The original project was a PhD that was co-funded by Scottish Forestry when we first started working with Sitka spruce sawdust provided by a Scottish sawmill, looking at lignin valorisation. And even still, our PhD has been really crucial to characterising and showing what the lignin is that is coming out from the Scottish Sitka spruce. And this is really important to the chemical companies. As anyone that's familiar with lignin, it is a crazily complex polymer. And so having this has been really, really helpful for our commercial development. Other projects in the pipeline, there's looking, Edinburgh University's Wallace Lab is looking at adipic acid from lignin, which is a route to bio-based nylon. The Future Fibre project is looking to melt spin the lignin into carbon fibres, which is a super high value potential end user product, and also one that's at high impact in terms of helping at the environmental footprint of carbon fibres. And then finally, from collaborations with through ICAST with the University of Bath and National Composite Centre, looking at sustainable composites, we've just launched a consortium project called the Karma Project, which is looking to develop net zero car materials with a consortium that includes the entire supply chain, right the way up to Polestar, a global electric car manufacturer, where we're looking to develop, think car dashboards like performance plastics, as well as the foam in the car seats, which currently is made with a really toxic chemical called isocyanate, which is horrible. So looking at ways that our biochemicals can improve those footprints and develop actual net zero car materials. So the next steps for us, how are we going to be providing value to Scottish Forestry? Well, we're currently working with Scottish feedstock and producing commercially viable platform chemicals to get out to the market. We're also developing, we're fundraising to raise the funds to design our first commercial plant through private, and we've just launched a Seeders campaign, which will actually be public on Monday. And through this, we're then looking to build a commercial plant up in Scotland. We're working closely with Scottish Enterprise and South of Scottish Enterprise to choose the location and help with the planning and ensure that we've got the regional support and involvement to really make this first commercial plant a success. There's likely to be about 15,000 tonnes of sawdust per year. Following that, that plant will be used as a demonstration plant in Scotland, from which we would look to expand the technology through further joint ventures around Scotland and the UK and international licensing opportunities. And alongside this, and this is really important, we are continuing our R&D into different feedstocks. So looking at different wood types, we keep having conversations with Scottish Forestry and Josh Roberts about looking at the commercial viability of different trees within Scotland, native trees and areas where other trees might be better grown, so that we can really plan for a sustainable future where in 30 years' time, trees that are really biodiverse and good for Scotland could potentially be turned into valuable biochemicals and create a really circular, sustainable bioeconomy from forestry in Scotland. So thank you very much. Really great to hear from you, and I'm looking forward to the next presentation a lot. Please get in touch. We can invite visits to our pilot plant if you're interested to see our technology in action, and otherwise I've got products that I can send to you. So let me know if you want to know more. Thank you very much.
Brilliant. Thanks, Miranda. That was a really good overview of Sonicchem's trajectory. Exciting times for you, and it's also great to see the crucial role you're going to play in the valorisation of Scotland's forestry residuals. So that was great.
And thank you for the support from IBIC. You guys have been amazing over the years.
That's good. That's good to hear. So we'll move on now to our next speaker, Stephen Adams. Stephen's research fellow at the Centre for Wood Science and Technology at Napier University in Edinburgh. And he's going to give us an overview of a tree extractives database that he was instrumental in developing in conjunction with IBIC, Forestry Scotland and RGU. So I'll hand over to you now, Stephen. Thank you.
Okay. thank you, Kim, and thank you, Miranda. Can you hear me and see me? Okay, I guess.
All looks good.
Okay. Yes, thanks, Miranda, for putting pressure on me there to say you're looking forward to this presentation. I don't think it will be that exciting. But yeah, I'm Stephen Adams. I work at Edinburgh Napier University. I work within the School of Computing and Engineering and Built Environment. But our group specifically looks at wood and wood properties, and looking at the different aspects of these properties depending on what the product is going to be, and relating that back to the forest and see how things could get, the wood or the properties or anything can get better used from that. This presentation is going to be about a database that we built, looking to log the extractives, the chemicals that you can find in the wood and in trees. I'll give you a bit of background on it, and then I was just going to give a quick run through of the database. So the background is that back in 2015, the Scottish government wanted to build more biorefineries to get less reliant on oil-based fuel and build more bio-based. As part of that, they thought that wood and wood products would be a good feedstock for that. As Miranda was saying, wood is, I'll not go into too much detail since she seemed to cover it quite well. So it's the cell wall, or the cells, are made of lignocellulosic material. So it's cellulose, hemicellulose, and lignin. But within that, within the wood, there's also other chemicals that we call extractives. But biorefineries convert cellulose and hemicellulose into biofuels, and to get more profitability, they thought they could use the separate out the lignin and use that for some other stuff, and then also the extractives. What could they extract these other chemicals out, and could they sell them? What can they be used for, and could they make more profitability out of that? So they account, depending on the species and whereabouts in the tree they account for about 0 to 10% of the wood. This varies greatly between different species, and it varies greatly depending on where in the tree that you're looking. They're not part of the wood structure like the cellulose and lignin. They're found and stored by the tree in different parts of the tree, so that they can be used in the processes that the tree needs to build itself. And they're called extractors because they're extracted from the wood using different chemicals, different solvents. And also a little note there that without knowing it, these chemicals have been used by humans for centuries in traditional medicines and stuff like that. So they have been used in the past. It's just people wouldn't have known what the chemicals were. So back in 2015, BioIC came to me and said, when the biorefinery roadmap was started, they said, can we look into, do a report on the extractive content of Scottish roundwood? The Scottish roundwood, the main species that they were looking at. So we looked up the Forestry Commission tables. They were called Forestry Commission in those days. I know they're called different things now, but in those days it was the Forestry Commission. And we found the principal species, the highest amount grown by volume, and mostly being Sitka spruce. But then we have these other species, Norway spruce, Scots pine larch, and lodgepole pine, which also are grown in quite significant amounts in Scotland. And what are the chemicals that are in these? So BioIC asked me to do a report on that, which it did, and it was basically just looking at the scientific literature, finding out what studies had been done. I didn't do any of the studies myself. I was just looking at what studies were out there on these 5 species to begin with, what they'd found, where in the tree they'd found them, and that was about it. That it didn't go any further than that. Just to look at what was out there, and what chemicals were in them. And from that, within that report, we were able to draw these pretty little pictures where you could have the species, and then you have the chemicals, and you could follow the map to see whereabouts in the tree they were. So that was all good. That was finished. But then BioIC came back and said, well, what about hardwoods? We've got plenty of hardwoods in there. In Scotland, there's not as many hardwoods as softwoods. There's still a significant amount, and in England there's a higher amount of them. So again, we looked up these Forestry Commission tables and found the highest amount grown, the highest 5 species, so oak, beech, sycamore, ash, and birch. And they wanted to look and see what extractives do these have, and whereabouts within the tree are they. But then, as part of that, they said, well, as well as identifying what chemicals are in there, this time, can we look and see what the potential uses of these chemicals are? So that if anybody was interested in it, then they would know what they were there. So for that, we got Robert Gordon University up in Aberdeen involved, who were the experts on that side. But BioIC also wanted, instead of a report this time, they asked, well, instead of it being a report, can we log all this in some sort of database? And that would mean including the previous reports, so all the softwood data that we'd found, as well as putting in new data for the new species that we were looking at, the hardwood species. And then also within that, could we also put in what the uses for these chemicals are? And then, as well as that, part of the project, and this was more on the BioIC side, but it's also our side, was to engage with people and get this information out there, with seminars like this. And it was also presented at one of the BioIC conferences back in 2019, I think it was. So we carried on with that and built this database. This is the landing page for the database. So I was just going to take through, see what it's like, see how you would actually use it. It's open to everybody. I think the web address is down here, so MD can use this. You can get a log, or I have a login, but the login is only for people that want to edit it. So MD else, you don't need a login. You can just come along and use it. So the main part of this is, we forget the search box. The best way to use this database is by using this menu over on the left-hand side, almost like a drop-down menu. So each one of these you can click on. So you can search it by the references if you know somebody's name that's done some studies. You can search it by tree parts. So if you click on tree parts, it just has a drop down of all the different parts of a tree, which you can then go on and click as well. And that takes you into, if you wanted to look at heartwood or sapwood, then you could click on them and see what chemicals are in there. You can look at it by species. So the drop-down menu has got all the tree species here. I've put in all the tree species, or not all the tree species, but a lot of tree species, but some of these aren't even populated yet because I've not even looked at them. But these are also clickable, so you can click on any of these and that takes you into the details of that. You can search it by extractives. So if you knew what chemical you were looking for, you can click on that, and it's alphabetical here. It gives you the structures and the formulas, and these are clickable, so you can go in and see them, or you can get links to PubChem. But also on this page, if you click on grid view, then we have all the structure, we've listed with all the structures, just in case you're a chemist and you know the functional group that you're looking for. You can scroll through this and find the different functional groups. And then we also have it searched by the application. So what you want, or if you know what the chemical area is that you're looking for, like anti-cancer or anti-diuretic, then you can click on this and you can find out what the chemicals are, where they are in the wood and stuff like that. And it was Cherry Wainwright up at Robert Gordon University that did this section for us. So I'll just take you through a little example of how you would search for these just now. So searching by species. So we have Sitka spruce, which is our most commonly grown tree species up in Scotland. I know that Miranda spoke about using Sitka spruce, but I know just from knowing that Sitka doesn't have that many extractives, and it has some, but as tree species go, it's quite low in extractives. But I'll take you through this one. So if you click on Sitka spruce, it brings up this little, this would be a full page normally, but I've cut it down. I've just screen printed it and cut them down to size just for the purposes of this presentation. So within that, this brings up the landing page for Sitka spruce. It shows you what group that is in. So like British spruce. So British spruce is just a classification of spruce grown in Britain. It would be Norway spruce and Sitka spruce. So it shows you what family it's in, and then up here we have the search observations for this species. So this is just, if you clicked on that, then it brings up all the results that we'd found for that species. So it gives you the species, where it was found, what it would be used for, the actual extractives that it was found, behind there, and then whether it was used in traditional medicine or not. The rating, they were all standard. That was just, it was put in there as a way of kind of looking at whether these references were reliable or not. And I'm not a chemist in that way, so I couldn't really tell if they were. Most of them they're all peer reviewed. They were all in good journals, so they should all be quite reliable. So most of these will just be in as standard. So if you go to the results page, you've clicked on Sitka. This is all the results for Sitka spruce. If you then click on the details box for whatever, if you see one of interest, you click on the details, and that brings up this landing page. So this is all the details of that observation. So this one, it says that the extractors were astringent and still beans. It's too small for me, I can't see that. So but then you click on that and it brings up this landing page. So this gives you that reference that it was related to. So it gives you the reference here, which you can click on, and that will take you to the actual, it won't take you to the paper, but it will take you to more details of the paper, the abstracts and stuff like that. It gives you a small summary of what the paper did or what the paper looked at. It gives you the species and what the application would be, and then it gives you the extractives. You click on the extractive, that would then bring up details of that extractive. So we have astringent here, and it gives you the chemical formulas. It gives you a picture of the formula. It gives you the names. It gives you all the chemical details of that. And then we also linked it to MolView and PubChem. So if you were more interested in that chemical, you didn't know exactly what it was, then we have linked it to these other websites where you can go and find out more details on it. So I think that's about it. It was just a quick run through of what the database is. That's the web address there. Go and use it. I think you could play about with it. I don't think you can break it. I hope you can't break it. You won't have a login, so I presume you won't be able to do anything on it. But yeah, if anybody has any questions on it, it's not complete yet, because I guess There's new studies being done all the time. New things should be added in there. We've put in as much details as we can, of much references of papers that we found, as many studies as we could possibly put in, but there's still plenty more that should be put in there. So if MD has any more information that they think, oh, this is missing, or papers that are missing, they can always get in contact with us, and we can try and put them in as well. So thank you for listening. If MD has any questions, you can let me know.
Brilliant. Thank you, Stephen. That was a nice bit of background to the development of the database and understanding its functionality and the wealth of really useful data that it contains. So thanks for that.
Okay.
So William, I'll hand over to you now. William Clark has been involved in the development of the Scottish circular bioeconomy for many years now, and recently joined Scottish Forestry as Forestry Transport and Innovation Advisor. So if you're ready, William.
Hi, Kim. Hi, everybody.
Yeah.
Thank you for the introduction. I'm just going to share my screen. Can you see that okay, Kim?
Yep, looks good. It's not in presenter mode, though. It's just, that's you. Yeah.
Yeah, thank you very much for the introduction, Kim. Today I'm going to be talking about a new approach to wood fibre, and I recognise this is quite a multidisciplinary audience today, and for anybody that doesn't know my organisation, we are Scottish Forestry. We are the government agency responsible for forestry policy support and regulations. A large part of my job is wood fibre innovation as well. So I just wanted to start with some facts. The first one is a wee bit abstract, but it has stuck with me from my first day in forestry. So in 1919, just at the end of the First World War, the UK nearly ran out of trees and timber. The woodland cover was actually less than 5%, and it's now more than 13.2% and increasing. But the following facts are more relevant. So the UK is the world's second biggest net importer of wood and wood products after China. On that basis, we are 80% dependent on imported wood. I would highlight that Scotland is a net exporter of wood. The UK is a net importer of wood. That accounts for around about £7.5 billion annually. It's worth noting that global demand for timber is going to increase by between 60 to 170% over the next 30 years. Within that as well, land use is always kind of elephant in the room. Agriculture's having the same conversation. Oddly enough, they need to increase their land use by 60% as well. So there is going to be some conflicts around about feed and fibre, or food and fibre in the near future. Please note, current value chains cannot sustainably meet this demand. From that, wood fibre innovation is a critical pathway, and industrial biotechnology is key. And I just want to, again, we're multidisciplinary. I just wanted to note that everybody has different meanings for different words in these contexts. So industrial biotechnology in my presentation can also mean circular bioeconomy, can also mean cascading refining, and a number of other product pathways, but industrial biotechnology is the best term to start with. So I wanted to give you an overview of the forestry in the UK. These statistics are taken from the Forestry Research document. It's 2022 statistical accounts, and this data is 2021. So the total wood produced in the UK in 2021 was 11,000 kilotons, 11,118,000 tonnes. And when you look at how that breaks down, we've heard a few bits about it already. 93% of that volume is in fact softwood, and 7% is hardwood. Now, going from the total production in the UK down to the subnational production statistics, softwood, as we said, is 93%, so that's 10,295,000 tonnes. And of that, around about 67%, or 6,870 kilotons, is produced here in Scotland. So when we're thinking about forestry, we're almost thinking about Scotland within that. And the other countries break down, so you've got England, then Wales, and then Ireland in order of the volumes of production. Now, thinking about that 7% of the UK production that is hardwood, and that is 823 kilotons. Steve mentioned that a second ago. The vast majority of that is in England. Scotland does produce volumes, and it's not to say that isn't a significant volume. It's just when you frame it into the wider context of forestry with the softwood story, it is very much focused through England. Now, breaking down that down a wee bit further, this again is taken from the same statistical account, but it is a survey of the 28 largest wood processors here in Scotland, so the total is slightly different to the previous figures given. So when you break down this is all softwood, as you can see, because that is the major component of the industry here in Scotland. You've got 6,679 kilotons is the total extraction. Around about a third of that is from public forests, which is Forest and Land Scotland, and the rest of that is from private. Now, when you break that figure down by use cases across all of these industries, the point I want to make here is there's actually there is no waste within this. So we need to remember that it's a very well established value chain, and each of the materials has value right the way through to bark at the far left bottom there, which has a number of horticultural applications. So just that there's very little waste. One thing that I would highlight within this as well as if we were talking about agriculture, I don't know if you're aware of the term everything but the oink in pig farming. One of the blessings and the curses of forestry is that the material lends itself to utilisation and cascading utilisation as well. So we're going to go around this clockwise today. So in the top left, we have a diagram showing the fate of different parts of the trees. So you've got the pruned logs, the saw logs at the bottom, which is for the major construction timber applications. You've got the saw logs in the middle, which is for, it's broken down into smaller parts, so it's finger jointed mouldings, industrial plywoods, engineered structural timbers, and a number of other products. As you go further up the tree, the number of applications is still there. So the industrial logs, that's the top section, but not quite the very top. If we break that down into a number of smaller products, again, that cascade in the final model. And then the diagram here is slightly wrong. I couldn't find one that worked for us here in Scotland. The land's really boggy, so when we're cutting trees, we use the brash in the tops of the trees, we put them on their side, and then that stops the machinery from sinking down into the bogs. So it's not that it's 100% utilisation, but the vast majority is used. I would highlight, moving around clockwise, we're on the second diagram. As mentioned, wood lends itself incredibly to utilisation. So it's a divergent supply chain. So that means that if you bought a log, as you can see going from left to right here for log manufacturing, you buy in a log, you'll make 5-10 products, and you'll sell those 10 products to the next guy. They'll take the one product and they'll make another 10 products. So it's actually getting utilised through the system very efficiently. And again, going back to what it's used for and how it's used, the diagram on the left bottom here shows that as the particles, as it's processed, as the wood's broken down into different products, we can still make a number of products out of it. So you've got plywood here as the sheet laminated. You've got orientated strand board, which is the chips from the higher up portions of the trees. Again, breaking it down, we've got particle board, which is taking the smaller components, putting them together using glue, making structural timber. And then you've got MDF, medium density fibre board, which is really taking the powder from the materials and utilising them. So what I'm saying is that the industry is actually incredibly efficient. It's been doing this for many, many years, and it's optimised to the point that it really does use almost all of the materials. Any materials that are left, such as the stumps, are left for a reason, because of the amount of carbon that I would realise from the soil. I would also highlight within this, a lot of the products that are made within forestry need to be dried. So traditionally, burning material might be seen as a waste management process. It is a lower value outcome when you look at the value adds that Miranda was talking about a wee while ago, but it's absolutely necessary for the industry to do that. So when we look at the diagrams on the right-hand side here, that's the industry. And if you imagine bioenergy is actually coming to each of these, so where they're not able to use any of their own co-products or byproducts, they're using it for energy, and it is a necessary part of the supply chain. That's not to say that the cost benefit wouldn't win if the types of figures that we've been hearing about were actualised. So the thing for me, that sounds like there isn't a lot of material available. There is, the cost benefit is always going to win. And the thing for me is that we need to remember that forestry is one of the key pillars of the bioeconomy. It's an incredible source of renewable, sustainable biomaterials, but then also the climate mitigation benefits that you get from it. So in my experience, having worked on pretty much every type of biomass, and now including forestry, there's not a lot of problems we can't solve. As we design out waste, as we design out fossil-based materials, we design in the bioeconomy, and again, wood lends itself perfectly to these types of technologies. So in the very near future, and we've heard about some incredible technologies, I'm really excited to hear more about them. So in the future, I'm already hearing about printed circuit boards being made from cellulose. We'll potentially be looking at nanocellulose, fibre optics, with an incredible range of uses, telecommunications, computers, application requiring high-speed networks. And one of the things that we're finding is that the natural materials, that very specifically lignocellulose, has properties that we don't occur in any other types of fibre optics. In this case, it's the hygroscopic nature of it. So we haven't identified specific use cases for this yet, but there are a number of people working on them. Frederick earlier on was talking about food applications through single-cell proteins. We could also be talking about direct uses, in this case where it's a functional ingredient. So you can actually use cellulose as a fat replacer in vegan foods. It's highly effective, and it's a brilliant additive to a number of foods where these types of functional ingredients are really important: sausages, mayonnaise, cakes. So when we're talking about the growth in wood fibre innovation value, we could also be talking about the market pull from these types of innovations and other sectors at the same time. So the demand, Miranda mentioned that the market pull for these types of materials is incredible. Some of my role is actually focused through timber transport as well. And another thing that I think we need to think about is, as fossil materials phase out, there's going to be some things that we can't actually do anymore. So I don't know if you were aware, bitumen asphalt is a co-product from oil production. It accounts for 95% of global road surfaces. Once fossils run out, or once we phase them out, how are we going to keep building roads? And it's use cases like this that I think are really important to bear in mind. So modified lignin can actually be substituted for bitumen and asphalt. It's nature-based, it's environmentally friendly, it's socially responsible, and it's renewable. So just as an illustration, there aren't a lot of problems that industrial biotechnology can't solve, and forestry is an ideal platform for taking these forward. So we might, in the future, be transporting wood on wood-based roads. As a final illustration, this is actually really interesting. So there's Spiridula and a team across SRUC, University of Edinburgh, University of St Andrews, an incredible group of other actors are working together, seeking to realise forestry byproducts as novel therapeutics for parasite controls in livestock. So it lends itself beautifully to Steve's presentation there. But one of the learnings for us from that is that not all trees are born equal. There's potential seasonality. So depending on what you're trying to do and how you're trying to do it, if you've got a medical application, you might need full traceability. If you've got a particular, you might be species agnostic, or you might need a particular species in a particular part of a particular species. So depending on how you're approaching what you're working on, there might be very different approaches that we would need to take account of to make sure that you were able to achieve high enough volumes, high enough concentrations in the molecules, and concentrations that are useful for your processes. So, in conclusion, I'm a cell biologist. I like to start small, and I like to think that this programme of work is following that same. So, today we've been talking about the molecular basis, and we're already talking about the next series of events around about wood fibre innovation as a subject. We've started off with biomolecules. I'd like to move that up to, we've heard a few applications around about materials, but then we'd also like to think about, things like wood fibre, but then also off out into construction at the same time. From that, having done this a couple of times now, collaboration is always key. I would highlight, if we can't see you, we can't hear you, we can't help you, so we really need to get in touch. We need to hear more about what you're doing, and we can potentially help you. And if we can't help you, we're happy to put you in touch with people that can help you. So please get in touch. Thank you very much, and there are my details.
Brilliant. Thanks, William. That was a really good sense of the kind of opportunities and challenges around the creation of value from Scottish Forestry residuals. So thanks very much for that. Let me just share my screen again. So we're going to move now and answer some of your questions. Let me just have a scroll through the chat box here. I think a few have been answered answered as we were going along. Let me just have a look through. So we've got one here for Miranda from Gail Shuttleworth. So Miranda's statistic that 45% of trees enter a sawmill and resulting in a valuable product, leaving 55% as lower value or sawdust. I was wondering what statistic would be when related back to a tree in the forest. So taking into account the amount that's left in the forest as brash trimmings, what would be the percentage of original growing tree that becomes a valuable product? Don't know, that's if you can drill down into that, Miranda, or would you need to take that one offline?
Yeah, I wouldn't be able to give a firm answer on that.
Yeah.
I'd ask some of our colleagues over at Scottish Forestry might have a better idea. But I do know there are some technologies that are really looking at bark as an input, and particularly following on the conversation about the extractives. A lot of the extractives are in the bark and the leaves and the other products. So there's value to be had from that if it could be harvested. But I believe at the moment it's not necessarily.
Right, yeah, that makes sense. Yeah, absolutely. There was one there, I don't know if you've answered it on in the background. It was about wood material from like furniture and consumer waste wood. I don't know if you wanted to respond to that. I think it said you said you'd answer that one live. Consumer waste wood as a feedstock.
Yeah, so consumer waste wood is a feedstock. We're not looking at it at the moment, and a lot of that is because it possibly has been treated, so there's additional chemicals in there. So something that's really important for a biorefinery to get right is you need consistent chemicals to go into your products, so that you know how to make them. And consumer wood, it's got other products in there. I know also there are other technologies that are looking at this and trying to develop products with that, whereby any varnishes or things could be removed or embodied in the product. But you have to consider things like that, seasonality of feedstock, and consistency. Is a tree that's grown, for example, out on the islands, does that have different chemicals or sort of minerals in it compared to one that's in the south of Scotland? So all these are considerations for the processing.
Yeah, I guess that's it. There's added complexities there. Once it's been treated in some way, you've got other factors to consider if you're going to valorize it. So,
but one of our goals, what we would love to be able to do is if we could make a 100% bio-based product from a wood product, could you then recycle it end of life through a process such as ours, when you really do have a truly circular? So that's our pipe dream where we want to get to.
Yeah, that would be the holy grail.
Yeah, exactly.
So yeah, that's great. Thank you. Let me see now. So kind of related to that, I guess, in some respects, Alistair Kerr's asking, a case is being made to displace low-value uses for sawmill products in favour of higher-value chemicals. And the question is it reasonable, however, to displace products that are essential to building furniture manufacture? guess that maybe is one for you again, Amanda. Hey, Miranda, rather.
I think, you know, with our target with this, what we're really hoping to displace is the burning of sawdust, where we think we can do better by locking up the carbon and putting it into a product. So our goal is not necessarily to displace that, but I guess we can't stop that from happening.
Yeah. Right, we'll give you a rest now, Miranda.
Thanks.
So just, I guess, one for everyone. Thoughts from the speakers on the role the forestry residuals can play in sustainable aviation fuel. I don't know who would like to take that one. Do you have any thoughts, William, on that?
Sorry, I'm not used to Zoom. I can't find the buttons. So this is a personal opinion, and perhaps doesn't reflect the position of my organisation. I've always seen aviation fuels as potentially a risk to the wider bio-based economies, just because of the value add that would give to the materials, potentially outweighing any value add that could be done at lower levels, if that makes sense. So it would potentially skew the types of bio-based materials, co-products that were left in the system for other people to act against, and your technology, whatever that is, would have to achieve the same value before you could compete for those materials. So I'm absolutely interested in it. I just think we need to be aware that there are potential outcomes that wouldn't work for everybody within that story.
Yeah.
Anybody
else? Sorry.
No, I was just going to come in on it. Certainly within forestry, we are actively pursuing decarbonisation through a number of mechanisms, electrification primarily, but that gets you to how are we generating electricity and the bio-based kind of components of that. We are looking at things like hydrated vegetable oils as replacements for diesel, but we're very, very interested in new developments. Thank you.
Thanks. Yeah. Anybody else have any comments or thoughts to add to that? There's another question which kind of leads on a bit there from Adrian Higgs and William. Are there any projects looking at alternative heat sources for the forestry industry to allow a move away from wood fuel? I guess you partially answered that.
They are, but they're very young. Again, I would highlight, we're in discussions around about follow-up events for next year, and that could be one of the themes that we pick up on. So there are technologies, they are IBIOIC members, but they would be better speaking to them than I am.
Yeah, okay. So this looks like another one for you, I'm afraid, William. Okay. Has Scottish Forestry done any calculation on the land take required for all of the potential innovation we've heard about today? Is this factored into the increase in demand that is already anticipated?
Woodland creation targets are already highly ambitious. I think we can only speak to Scotland rather than the global situation, but there's certainly a lot of efforts in place around about increasing that area. Whether or not it matches against the types of increases that we're looking at is another story.
Thanks. Miranda, there's a question here from Spiridula. Where are we now? Sorry. About bottlenecks. Or maybe you've answered that one, have you? Sorry, you have. Yeah, there was just a follow-up question in the thread there, so I think you've answered it in the... just look through here. Is there any exploration of other wastes connected with the forestry industry? So plants like gorse and broom and so on that are often connected with the maintenance of new plantations. So that's probably going to land back with you again, William, isn't it?
Non-timber forest products is part of my role at Scottish Forestry. We need to be mindful of Scottish Forestry's role within this. So we are regulators rather than actors. There is an industry in Scotland, but I would be very keen to understand how much there is out there, and we could potentially have another conversation on bioextractives from the non-timber forest product part of that. I think there's also been some really interesting conversations with the more done around about different models of agroforestry. So starting to look at almost a integrated multi-trophic forestry, the same way we think about agriculture. So growing these types of products deliberately as a farming model underneath the canopies. So please get in touch. I'd be interested to hear more about people who are working in that space.
Thanks.
I think sorry.
When you go.
I was just going to say, Steve made a great point around about, a lot of what we're talking about today, some of what we're talking about today is very, very traditional medicines, and a lot of these types of non-timber forest products lend themselves very much to that. So, like I said, please get in touch.
Yeah. Thanks. Just scrolling. I think we've covered all the questions that are here in the Q&A box, but if I've missed anyone, please let me know and we can follow up after the session. So I'm just going to move on now to talk about the support that's available through the Bioeconomy Cluster Builder. We can provide access to for commercial and technical support through the extensive networks of the partner organisations, so the Industrial Biotechnology Innovation Centre and Innovate UK KTN. And we're also able to convene challenge-based focus groups and round tables to help companies progress solutions to specific challenges. So you get in touch with us, we'll be happy to pull together a group of relevant stakeholders to help with that. We offer signposting to funding opportunities. So I'm going to speak in a moment about a current Innovate UK Launchpad call that's running just now. And we also can provide information about potential supplies of feedstocks for biotech processes through the bioresource mapping tool, which is a collaboration between BioIC, Scottish Enterprise, and Zero Waste Scotland. And so further details about the BCB project and recordings of past events are available on the website. The website's just down in the bottom left-hand corner of the screen there. And just to echo William's comments, we're here to help. So if you have any ideas that you'd like to take forward, any challenges that you're encountering, please do get in touch. I'll put my contact details on towards the end of the presentation and be happy to help you try and move things forward. So as promised, some information about the current Innovate UK Launchpad calls that are running at the moment. So this is a 2 million pot for the round one call, and it's funding for industry-led projects. Focus areas are industrial biotechnology, biomass supply chain development, sustainable production and manufacturing, either individually or combinations of, and applications should contribute to equality, diversity and inclusivity, and from companies that are active or that are growing their activity in Scotland. As I said, the call's open now and it closes at 11 AM on Wednesday, the 13th of December. Partners in the delivery of the Launchpad, BioIC, Innovate UK KTN, Scottish Enterprise and Forth Valley College. And so the first of the calls is a collaborative R&D call, awards between 150,000 and 1 million. And on a sliding scale, depending on awards are on a percentage sliding scale dependent on the size of the company. Projects should be 6 to 18 months in duration, kicking off on the 1st of April next year at the earliest and ending at the end of March 2026 at the latest. And they can be led by a UK business of any size, but they have to include at least one SME. There's a QR code on the right-hand side there that should take you through to the to further details about the call. And as my email address is in the bottom left-hand corner there if you want to get in touch to find out more. And the second call is under something termed minimal financial assistance. So this must meet government criteria for public body funding of commercial enterprises. So that is that the funding shouldn't exceed £315,000 in a rolling 3-year period. And for this one, awards between 25,000 and 100,000 up to 100% of project costs, 6 to 12 months in duration. So beginning on the 1st of April 24 at the earliest and ending at the end of April 25 at the latest. And these have to be led by UK SME. So again, there's a QR code there that should take you through to the relevant webpage. Any issues with that, then drop me a line at the email address there on the bottom left. And lastly, a shameless plug for next year's iBioYC conference. So it's running in Glasgow on the 13th and 14th of March. The theme of transformation of the biotechnology landscape in Scotland in the 10 years since iBioYC was formed. And this will be the focal point of Bioeconomy Weeks, which is running all of that week from the 11th to the 15th of March. So the conference will be comprised of sessions, workshops, networking opportunities. There'll be an exhibition space, and we'll have an extended civic reception at the City Chambers in Glasgow. Once again, there's a QR code on the right-hand side, which will take you through to a dedicated web page with more information about the conference. Registration is open now. There's also a web link in the bottom left-hand side, so you can use that. And again, get in touch if you have any questions. So with that, thank you to all of our fantastic speakers today. Excellent contributions, and thanks to everyone who's worked behind the scenes to pull today's event together. And a big thank you to all of you for joining us. Contact details on the screen here. And once again, a recording of the event will be available on the Bioeconomy Cluster website shortly after it runs. And subject to agreement with the speakers, we'll be able to share slides with you as well. So thanks much again, and enjoy the rest of your day.